guest lecture session, which holds an immense importance in our professional journey. Mechanical opportunities in aerospace and defense sectors. Mechanical opportunities in aerospace and defense sectors encompass a dynamic critical field of engineering. Mechanical engineers play a pivotal role in advancing technology and safeguarding national security. Now, without any further ado, let me invite our beloved HOD sir, Dr. T. Srinivas Rao garu.
Respected today's guest, V. Naga Srinivas garu, Naga datta Srinivas garu. Respected our beloved principal, Y. Mallikarjun Reddy garu, Dean Academics, Dr. G. Girubabu garu, faculty, colleagues, and my dear students, good morning all. I welcome wholeheartedly Naga datta Srinivas garu to welcome to this program. My sincere thanks to accepting our request for this program. Okay, as you all know that for mechanical students, industrial exposure is very important. It is a crucial thing also, right? You all know that a part of teaching learning, you should learn continuously. Things are available, some things are available in our textbooks. Some things should be available through the exposure only, that to industrial exposure only. So if you want to get industrial exposure, a right person is required. In that direction, we have chosen Mr. Srinivas garu, right? He is the right person. He has vast experience in the industrial field. Right. Next, my sincere thanks to our beloved Principal Garu and Dean Academics, enabled to conduct this program smoothly. Okay, thank you. Now I hand over session to the Naga Srinivas Garu.
Am I audible? Sir. Okay, thank you. First of all, let me introduce myself. This is Naga datta Srinivas. Basically, I am from a village, Maripodi, near Bapatla. The entire schooling, I think we have completed from APRS Tadikonda, and your professors are my colleagues, my classmates there. And after that, I had my bachelor's in mechanical engineering from Bapatla Engineering College. At that time, it is affiliated to Nagara University. And after that, I had my master's in NIT Calicut in manufacturing technology. So at that time, I couldn't get a chance to have a campus placement. So I got an opportunity to work in IIT Mechanical Engineering Department, Delhi, as a research associate cum junior scientist. So we worked with Professor P.V. Madhusudhana sir for 2.5 years. I think he will be in top 5 in CAD/CAM industry. So after that, in 2002, I joined as a software engineer in Infotech Enterprise Limited. After that, I worked at various levels. Now I think I'm working as a customer interface manager cum principal lead, like that. As a part of this journey, I could get an opportunity to work with different aerospace customers like some sort of Pratt & Whitney, Boeing, GKN, DL Air Cabin, Triumphant, IHA, something like that. In this journey, I think I could get a chance to visit different countries like USA, UK, Japan, and Germany, like that. So this is about my professional background. So now let me introduce my company also, and after that we'll go back to our today's topic. Okay. Yeah, I think, are you able to see it, right? This is, are you able to see the screen? Can you switch off this light, please? Yeah. Please. Is it okay? So this is You have this monitor. Yeah. Okay. Yes. Now, this is my company, Infotech Enterprises Limited, that is established or started by Dr. B.V.R. Mohan Reddy in 1991. Okay, and at that time they have started this company with 4 people on a dining table, and basically they are creating the drawings and sent to the customers in floppies at that time. I think floppy, you may be knowing that, now it is pen drives and all. At that time it is 1.5 MB, so that is a floppy. Okay, and after that in 2000, and we could get a chance to work with different customers like all aerospace, defense, transportation, oil and gas industries, medical, some sort of mining, different customers. In 2014, it is rebranded as Cyient, CYIENT, because there were around 650 companies with the name Infotech in the world. So to have uniqueness, we rebranded as Cyient Limited from there. So I think we have different customers. Now that 4 people now becomes transformed to around more than 16,000 people right now. The good news for you is, out of 16,000, more than 90% of the people are from mechanical engineers. We do work for aerospace industries, transportation, medical, like that. Okay, this is our company. We are situated at different locations: Madhapur, Hyderabad, Vizag, Bengaluru, Noida, and different countries like USA, UK, Germany, like that. So these are all. This is our campus in Manikonda. The middle block, I think. So this middle building I am sitting there. This is the Manikonda campus facility. So this is about our company. Okay. Yeah. So I think I already told these are all the different companies like customers we are working. So I think first of all, I think how many of you have in final year and third year, second year like that? Can you please raise your hands? Final year, second year, third year, right? Okay. So first of all, at industry, it's used to call as a customers and suppliers. So who is the customer and who is the supplier? Can anybody please? Yeah, please, I think this is an interactive session. I just wanted to participate, you people. I think it's a friendly session. I just wanted to share my experiences so that you will be getting a confidence in the mechanical industry in future. So that is what is the objective of it. I'm not going to share my feedback to your professors like that. So please feel free. And so who is the customer and who is the supplier here? A customer is nothing but who takes the services, right? A supplier is nothing but who provides services, right? So we have worked for different customers in industries. So, sorry, yeah. So before starting of the topic, I just wanted to know. So what is this? Turbine? Compressor? Okay, this is aircraft engine. When you see the flight, right, we have 4 engines, 2 on that side and 2 on the other side, right? So this is the raw look of this aircraft engine, right? So what is this? This is the wing structure, right? Under that we have the engines, right? What is this? How many of you boarded into flight right till now? Good. So this is the seating arrangement as well as interiors. The entire interiors will be covered with a plastic-like materials. You can open a window for light, but you cannot open a window for air, right? Because at that time, at that speed, you can't go with that, right? So this is interiors. So who are in the industry, in the world, in the aerospace industry, That is a topic right now, right? Mechanical opportunities in aerospace and defense, right? Who are the manufacturers of the aerospace engines? Aerospace engines are aircrafts. Anybody? Okay, so Boeing and Airbus are the leading. I'm not saying other, there are some other people are there. I'm saying leading. Boeing and Airbus are the leading. So in order to manufacture a flight, there are many things, like already told, interiors are there, electrical systems are there, as well as engines are there, like that, right? So they are not going to manufacture these things on their own, right? They are outsourcing these things to other suppliers. Suppose Pratt and Whitney and GE are the two companies who are going to manufacture aircraft engines, right? Maybe D Air Cabin is taking care of this entire interiors, and GKN is taking care of the entire wing structure. These are all the different aerospace companies. So Boeing and Airbus are the two manufacturers of the aircraft which are going to outsource their work to other suppliers. So I think fortunately or unfortunately, we are working for both Boeing as well as Airbus and their suppliers like Utah's Aerospace, Collins, GKN, D Air Cabin, Trimefort. Don't worry about these companies. These are the different companies working in the aerospace industries. So I think I told right who are the manufacturing of these companies like that. So if you take engine of this engine, it is having more than 1200 components. It's a sequence of some sort of nozzles, turbines, compressors, something like nacelles, something like that. Similarly, the wing structure is also, there are many wing structure is also like that. Similarly, interiors, the entire interiors, ducting used for electric systems, of ACs and all will be used for them. So this is the way we are going to manufacture and we are working on that. Now, first of all, if you go to this, so in aerospace and defense, these are all the possible opportunities. First of all, if you see mechanical design and modeling and analysis, manufacturing, aftermarket and technical publications, as well as automation and customizations. We'll go each and every topic one by one. Okay. So this is what are the opportunities. Along with that, there are many other opportunities like value engineering, weight reduction, test engineering. There are many things. So we have full of opportunities in mechanical engineering. That's what we are going to see right now today. See, I think we are using cars, trains, right, bikes and all. So in every part there is a mechanical component is there, is it not? We are using ACs, we are using some sort of refrigerators. Everywhere mechanical components are there. Whether it is a software or hardware or mechanical work, definitely we have full of opportunities in the mechanical industries. There is no need to bother about that. It's an evergreen branch, because for the last 25 years I have been working in the same mechanical field with software knowledge. Okay. So we'll talk about what is that mechanical design and manufacturing. So when I went to USA in 2009, so I wanted to go to Chicago. At that time, I need to take a flight in Bombay, from the Bombay to Frankfurt and Frankfurt to Chicago, 2 flights. I think there is a breakdown of 2 hours journey in between that. So right now, which you take in 2016, I can directly take a flight from Bombay to Chicago, 14 hours continuously. So what is that? This is improvement, right? So every variant, every version of this particular aircraft is come up with new features, either to improve the efficiency, improve the fuel economy, reducing the weight, reducing the noise, improving the comfortness, improving the seating capacity. All these things are part of the different features of the new variant or new versions. When you take Boeing 787, Airbus 320, all are different versions of the flight. So what are the first opportunity if you see in the mechanical industry? So this is it. So how many of you know CAD packages? Do you know any CAD packages? Can you please tell any names you CAD packages of the names? I don't ask you to create a model. Yes. NX is from Siemens, right? KTI is from Dassault Systems, and Creo is from Parametric Technology, PTC, right? These are the different CAD packages available. So what we are going to do with the CAD packages? So some people are using CATIA, some people are using NX, some people are using Creo, something like that. But based on the requirement from the customers, we are going to create the entire model, entire design, entire drawing, entire assembly into the systems by using CAD packages, right? If you know, I think if you know NX, maybe Pratt & Whitney using mainly NX, maybe Bombardier using CATIA, something like that. So other people are using Creo, something like that. So if you know one CAD package, when you join to the industry, immediately they are going to try in other CAD packages or required CAD packages, and we are going to work on creation of the mechanical models like a turbine. I already told you more than 12,000 components are there in the simple engine. There are many things in the interiors, many things in the wing structure, many things in the electric systems, ground support systems. There are many things. So the first opportunity is mechanical design. And once after the design is there, we are going to go for the assembly. And assembly is there, we are going to go the drawing. So creation of the orthographic views, section views, detail views, and all are the part of this drawing. So once you have created any model or a drawing using CAD package, definitely there should be a quality checking, right? What is quality checking? Whether we have followed the rules or not, any deviations are there, the experienced people are going to do that, right? Because in the drawing is by seeing the manufacturer, by seeing the drawing itself, he is able to create the manufacturing. So entire information has to be there in that. If any dimension is missing, or any view is missing, something like that, right? So this is the quality checking process. So the mechanical modeling, drawing, assembling, everything is part of the CAD packages we are using manually on the computers, creation of these models. So this is one opportunity where we are going with that. The second opportunity is analysis. I think second year and third year, right? I don't think you might have completed this FEM, right? Finite element method, right? Anybody has heard about that? Okay, finite element method is nothing but a methodology where we are going to simulate, or where we are going to simulate the entire model on the screen itself by applying the boundary conditions, by applying the loads, by applying the materials, and finally you are going to form a system of equations and we are going to solve it. With that we are able to get the results like where it is getting failed due to static structure or something like that. So if it is static body, we are going to do the static analysis. If it is a vibrating body, you are going to do the modeling analysis. Maybe it's because of thermals and anything, you are going to come up with thermal analysis, right? So for all these things, our customers are asking us to use ANSYS, what is that other type? LS Dyna, Nastran, Patron. These are the packages we are using specified by the customer, and we are going to create the entire model what you have developed in the NX, that is being imported into ANSYS or HyperMesh. First of all, you are going to divide into different small elements, right? And after that we are going to apply the boundary conditions, apply the loads, apply materials, and finally you are going to end up with the solution where you are going to, suppose a particular component is getting failed. So why it is failing that? Is there any way to improve that? In such case that adding the material, or maybe avoiding the sharp corners, adding some blends, something like that. Again it has to go from the model, that's analysis model, to again design. They are remodifying redesigning that, again go back to analysis. So this is the way where you are using the meshing. A HyperMesh is with a very good package used for dividing the entire body into some different materials. Okay. Then pre-processing is, I already told you, applying the loads, boundary conditions, materials, and finally we are going to end up with a solution, solving the system of equations. We are going to end up with where, I think if aerofoil is there in the nozzle, so where that red color is there, right? There is that is what is the failure. So how to avoid this failure? By maybe adding some more curvature, or adding the material, avoiding sharp corners. So this is one type of opportunity in aerospace industry where our engineers are working like that. So this is the second opportunity. I think moving back to the third opportunity, this is manufacturing. If you see this manufacturing workshop of entire aircraft, so I have taken all these pictures from the internet. Don't worry, I think you will be finding those things in the internet itself. So in the manufacturing again, there are many things, right? Whenever you are doing manufacturing, you need to take care of tooling, jigs and fixtures, CNC program, manufacturing operations, that is job creations, as well as applying the material, tolerance and specifications, accuracy. There are many things. So by using the CAD packages, we have different modules. One is modeling module, drafting module, analysis module, that is CAE, manufacturing modules like that. There are many modules. So by using this or by using analysis packages we can generate the CNC programming, and finally you are going to end up with this manufacturing. This is the third thing. This is also very good thing. So whenever you are working on the design, I think you will be having more opportunities to locate in the on-site with the customer like US or Germany, and along with the customer you are going to create it. That is one opportunity we have. In the analysis side, we think we need to use our knowledge, and after doing the solution, you need to identify why it is failing, that what is the remedy of it, how to recover that. All those things will be part of the analysis. Now the manufacturing. Now coming back to aftermarketing. What is this aftermarketing? Technical publication. So whenever you are buying some sort of a mobile, right? So immediately they are going to give some manual, right? So inside that there are some sort of troubleshooting, some manuals are there. Similarly, aircraft engine is there. They are going to write the entire, because like a physician and the doctor, whenever you have something, I think you went to the doctor, I think they are going to give some medicines. I think he has the complete knowledge of the entire body. Similarly, the aftermarketing and technical publication writers have the knowledge of each and every component of the aircraft. So they are going to write the manuals, overhauling service procedures, as well as minor repairs, replacements, alternates. All these things will be part of this. They are using some sort of PDF writers or HTML, XML, like that they are going to prepare these manuals. This is the fourth opportunity. Now along with, I already told you, suppose the value engineering. Value engineering is nothing but, so whenever the bill of materials are there, you wanted to reduce the bill of materials. So you wanted to take out the component or combine the different components in such a way that the functionality will be remains. So that we are adding some value to the assembly or something like that. So this is value engineering. Whenever you are already made the component, that POC has to be tested physically, like some sort of fog test, environment test, rust test, some testing is going. That is a different subject. Again, one more opportunity. So these are all the possible opportunities where we are using either CAD packages or analysis packages manually on the system. We are going to do that. This is what these are the opportunities. Now we go back to automation. What is this? Can anybody give us any definition or what is automation? Okay, I'll give you some, in simple words, automation is nothing but usage of computers, avoiding or eliminating manual intervention, improving the productivity, as well as getting the consistent results. Is it not the automation? So, can anybody give some example of automation in general industry? Sorry? Manufacturing. What is manufacturing? Yeah, see, because CNC programming, earlier we are doing it manually, but now, yes, that is up to automation. Okay, I'll give an example, right? Suppose, I'll come back to the customization back. So, okay, what is customization? Customization is nothing but, suppose a PowerPoint presentation, knowing, right? The technical people are using some of the options in the PowerPoint presentation, and HR people are using some more options to have look and feel, right? The sales people are using more, adding animations, adding pictures, right, adding colors, all these things, sales. So the same PowerPoint presentation will be used by different people in different fashions, right? In the same fashion, whatever it is required, we are keeping it. Whatever is not required, we are keeping out, like that. As well as adding our own behavior, adding our own menu items. All these things are part of the customization. I'll come back to that. So I think we need to discuss about what is automation, right? In the automation, IRCTC site is the best example. Everybody knows about that. I think most of the people have used the IRCTC site for booking the tickets, right? So what is that? What is that automation we have done here? In 1990s or 96 or 97, when after completing our BTech, after writing the competitive examinations, for going to Hyderabad, we are going to Vapata railway station and standing in a queue and filling a form and giving that. At that time, for each train, each station, there is a quota. Based on the availability, they are going to give some sort of pink tickets and writing on the background that mail something 40 something like that, as well as the train number and all these things. So nowadays, from your system itself, from your laptop or from your house, you are able to see the trains, you are able to see the availability of the tickets, you are able to give the inputs, and you are able to pay the amount, and your ticket is coming to your mobile, right? So this is the background situation also I told you. Now the current situation, this is a perfect example of automation. So wherever the human intervention, time, all these things are time, there is no need to go to the railway station now. From here itself I can book that if internet is there, right? I can see the availability, all these things. So this is one example. Coming back to mechanical industry. So what is that automation in the mechanical industry? Earlier our people, drafters, are using mini drafters and creating the front view, side view, top view by using on the drawing sheets. There is some sort of big platform, something like that, right? Now there is no need. Once you create the isometric view in the 3D model, you are able to create a front view, side view, top view, and automatic dimensions. Everything you are able to create it. Is it not? So this is also one more automation. Now the question is, I am asking one more question here. So I am able to create the front view, side view, top view from the 3D model by using CAD packages. Is there any CAD package in the world? Can I supply front view, top view, side view, and I am able to get the 3D model directly? Is there any package available? Yes or no? It's obviously no, because whenever you are seeing the front view, side view and top view, you are going to imagine something in your mind, 3D model, and you start creating that. Maybe after seeing the side view, detail view, something, you are going to iteratively, you are going to end up with the thing. So whatever the thinking process, whatever the imagination you are doing on your mind cannot be converted into generic rules, which cannot be put into the software system. That is why drawing to model is not possible. Whereas in IRCTC site, irrespective of the station, irrespective of the train, irrespective of male or female, we are able to create, irrespective of quota, Tatkal quota, general quota, something, we are able to create it. So whatever the generic procedure is available can be converted into rules, which can be converted into, put into the system that can be automated. On the other hand, drawing to model, our imagination can't be converted. That is why we are not able to create the 3D model from the drawings. Are you following it? Right? So that is one criteria. Wherever the generic procedure is there, in our mechanical industry also, we are able to automate. That is the topic I am going to discuss right now. Okay. So is the generic procedure itself is required, is sufficient for doing the automation? Is there any other criteria is available? When you come back to that, so IRCTC site will be using by hundreds of users daily, thousands of users on a weekly basis, maybe thousands of people on monthly basis. That is why they have created an app which can be used that. Suppose 2 months back, I think we have completed Chandrayaan 3, right? They are going to do only one iteration in the span of 2 years. It's till that point of time that is not repetitive. So if it is not repetitive activity, we are not going to do the automation. So generic procedure as well as repeatability are the two criteria for doing the automation. So that is the reason I think I have already told IRCTC package is one automation example. All your bus tickets, electric bill payment, Airtel bill payment, all these things are part of that. And where drawing to model is not possible because of we are unable to convert our imagination to generic rules. So this is what is the automation. So why we are all discussing about this automation? Because whenever you are doing automation, automatically we are improving the productivity, getting the consistency, right? You eliminating the human intervention. All these things are the benefits of this automation. That is why we are doing. So why we are discussing all these things here? So in the mechanical industry also, we are able to automate the process of creation, either by using some sort of programming or macros or anything. We are able to do that. That is what we are doing for the last 20 years in the aerospace industry, which I am going to explain to you now. So for that all, I think I am telling all this story here. Okay. Now, so suppose if you open a Word document and you are creating your biodata or something like that, writing your name, male, female, be it intermediate marks, 10th class marks, and at the end of it, what you are going to do? You are going to save the document by clicking on the save button, right, in MS Word. Once you click on the save button, what you are going to get? You are going to end up with a screen, right? What is that screen? It is asking what is the name of the document, what is the location of the document, right? As well as you wanted to create you wanted to save in the Word format or WordX format, DocX format or HTML format, something like that is asking, right? So when you click on a button, something is getting displayed. What is that? If you understand it, if you click on a button, something is executing at the back end. As a result, we are getting some dialogue. Some function is getting executed at the back end. That is what. So what do you mean by function here? Think how many of you completed C programming or C++ programming in your curriculum? All. What is the function then? A function in C or method in Java or subroutine in Fortran. What is that? No problem. You can just tell it. Okay, it may be wrong. No issues. Okay, a function is a sequence of statements which will be written for a specific purpose. Suppose in a bank account is there, right? A bank account, there are thousands, lakhs of account holders are there. Every 6 months they are going to put some interest, right? So this has to be done for each and every account holder. Suppose I have some money in that, I have some money in my account for a period of 6 months for a rate of interest 2.43%. So what is that? At the PNR by 100 something. So I am going to write a function which I am going to call for each and every customer. That is a repetitive action. So that is called nothing but a function. So when you click on this Word document save button, a function is getting called at the back end. Because of that, it is going to display one dialog where you are giving the file name, location as well as format. When you click on save, something else is getting executed at the back end, and finally you are going to save your document for using purpose. So this is what is happening. In CAD package also, whenever you click on something, something is getting executed at the back end. So what is that? We need to understand. So if what function is executing and what is the output you are going to generate it, this is called application programming interface, API. API is nothing but, suppose if you are going to some sort of shop for buying a lock, right? So what is that? You are going, the shop owner is going to provide some locks. We are going to see whether the lock is opening or not, something like that. And we are based on the cost or based on the strength, we are going to purchase it. But we are not bothering about whether it is a lever mechanism or spring mechanism. We are not bothering about that, right? So in the same fashion, so a function is there. The function is, the name of the function is this. The function is doing this purpose. This function will take these inputs. This function will generate this output. So that type of help document, every CAD package is going to provide to us. So this function is going to do something. This function is going to do something. These are the inputs we are going to supply, and this is output is going to provide. So this is called API, Application Programming Interface. If you are able to learn, and one more thing I am telling you is, each CAD package, to grab many users, they are providing API in different languages, C language, C++ language, Java, Python, C#, something like that. So they are not going to develop the CAD package in different languages. The same language, same package will be called from different languages. The chocolate is same, wrappers are different. Because whenever you wanted to add any feature to the CAD package, I think with one time only we are doing it, instead of doing for 5 times, Java, one time in Java, one time in Python, something like that. So this is what is the API we are using in our mechanical industry, by using CAD packages, we are able to execute and generate the results. So that is what. Suppose if you take NX API in C program is called ufunc, NX API in C Sharp it is calling NX Open, something like that in CATIA CIA, some sort of .NET API, in ANSYS APDL, all these are programming languages. So what I mean to say is that if you know the programming like C or C++, Java, Python, you are able to execute these mechanical programs by using CAD packages and automate the process, which is very, very hard work in an industrial market. So that is what I can say. So I will give you an example here. So what is this automation wherever it is possible? I will try to give 2 examples here. If possible, I will try to show 2 videos also here. So what is that? And then you will be knowing that. Suppose in mechanical industry, aircraft engine having 1200, more than 1200 components. So they are divided into assemblies and sub-assemblies, something like that, right? So whenever, for each aircraft engine, they are going to give some sort of a limit on the weight. They are not going to not going to be more than something. So that limit will be there. Whenever they are changing the geometry, they are adding the materials, they are going to cross check whether my weight of the component is within the limits or not. So in a CAD package, if you wanted to see the weight, what is the weight? Mass into density, something like that, into quantity, right? So go to the material properties of that and get the volume, get the density and calculate it. So for 1200 components, how many times you need to multiply that? 1200 times, like that. So they are asking that every time we wanted to calculate the weight, it's a very cumbersome process for us. We are doing many human mistakes. Instead of that, can you automate this process? Can you write a program to automate this? We have written that. That's what I wanted to show that. Okay. So what we are doing is we have written a simple macro. We have added a menu item in the NX package. When you click on it, a dialog will be opened. So which Excel sheet, what is the name of the Excel sheet you wanted to save that? Click on OK. Automatically, I am going to end up with this like that. What is the part description, part number, as well as area, volume, geometrical properties like moment of inertia, as well as surface area, what is center of gravity, all the information we are able to. Once you get the information, you can put it in the Word format, Excel format, PowerPoint presentation format. So almost 2.5 to 3 hours of time is reducing it to maximum 1 minute. And we are getting the consistent results. This is called one automation in the aerospace industry. So that is what people are looking for. Now the second part is, so this is, I think for your understanding sake, I am just telling that. This is called a whole location chart. Whole location chart is nothing but, suppose if you have a rotor like this, and it is having different holes, like number of holes, right? Suppose you wanted to create a CNC program or NC program on that. So what they want is, from a reference hole, they need to have the horizontal and vertical dimensions, so that they can easily use G0 and G01, G02 commands, and using drill for a drilling, they are going to create the NC and CNC programs. So this is what they are expecting from us. So but in order to create that, so every dimension has to be created horizontally, vertically, and they are going to disable that leader lines, and this is the output of it. So in order to create that, they are taking 8 hours of time. Creation of the dimensions, disabling it, and put it in the proper format. At the end of it, if you wanted to insert one more hole, again they have to recreate that, right? Are you able to follow it? Yeah. So what we are doing is, we have created a small GUI like this, graphical interface. So first is select view. So by using this view, we are able to select this view. First it is asking, what is the reference hole? I am selecting the reference hole like this. Select all other holes, 1, 2, 3, 4, 5, 6, all selecting all the holes. Then it is asking, you want to create at a default location or at different location. Then we will take the location. And finally, we are going to end up with what is the number of rows per chart, because it may overlap with some other views. That is why 8 views or 6 views or 10 views, something like that. So this is the way we are going to create it. When you click on, once it is created, again if you rerun the application, and after selecting the view, automatically the previous things also will be displayed. You can add some new rows or new holes here. At the end, we are going to come up with this. So this is one more automation. I think if I can show this on the screen video, I think you will be understanding that, because based on your level of understanding, I just came up with this example. So these like this, you can do many automations in the mechanical industry. Suppose I wanted to calculate, I want to design some sort of flywheel. I think you have some sort of procedure for doing the flywheel. You need to go to the database for getting some material properties, some temperature properties, all these things. So all these things can be digitized, and whenever you are giving the inputs, automatically we are going to write the formulas inside the system. At the end of it, I am going to end up with the complete design procedures. So this is a way you are going to use this designs for automating it, maybe weight optimization or improving the efficiency, different things. By changing one parameter, I am going to end up with this. Like that, you can play with the stores. These are all the mechanical possible automations available using CAD packages. Not only that, analysis packages also. Yeah, this is one more example. So whenever a drill bit, because Kennametal is a company who is going to manufacturing different drill bits. So this is you can see this is the drill bit, this is the shank, and this is the drilled portion. This is the spiral footed, triple footed. This is the clamping surface. This is the coolant. All these things. So what they are asking us, whenever they are giving some parameters on the interface, we are going to calculate the entire design of the parameters, and finally you are going to create this corresponding 3D model as well as 2D drawings automatically, so that the customer can see these drawings and finally end up with whether they are going to buy it or not, like that. So this is one more automation in the CAD industry. Now, I think till this point of time I am talking about only CAD packages and analysis packages. Along with that, product lifecycle management is also one tool. So what is that, product lifecycle management? Product lifecycle management is nothing but, because our customer is there in US and we are suppliers at Hyderabad, and somebody sales people is there at some other locations. Because whenever a part is manufacturing or part is designed, we need to have different documents or CAD parts, like design, this NX model should be required, what is that NX drawing should be required, aftermarket information, CNC programs, tolerance information, sales information, every information has to be there at a single locations. So that is one thing. As well as, so authorized users are able to access the authorized documents. So only design people can access the design material. Manufacturing people can access the manufacturing documents, like that. A single system which is going to access it by all the users of this particular product, and which is providing the access, write permissions, read permissions, all these things, that is nothing but a product lifecycle management. So in industry, Siemens is coming up with the Team Center. That is one thing. Team Center is the platform where you can access all the information in a single go, latest information. Similarly, Enovia from Dassault as well as Windchill from PTC. So these are the different product lifecycle management, like that. So along with this, because the information about the product is, see, design, analysis, tooling, machining, assembly, robotics, simulation, production, all the information will be available at a single location, which will be accessed by a single tool is called Team Center or Enovia or Windchill. So this is one very hot cake in the market now. When you have any knowledge about this Team Center or Enovia or anything, you will be getting many opportunities in the industry. So now we'll come back to, along with this Team Center, again as I told you, creation of the model manually is the design in CAD package. Similarly, opening and check-in and check-out and creating the CAD models, analysis models, all these things will be part of the Team Center user level applications. Similarly, if you wanted to have a system which is representing our company, because organization, right? So we are customizing our own company by using administrator level. The third thing is, instead of doing manually, I am able to write some programs for finally end up with the customization support. So this is the three type of varieties of opportunities in Team Center or PLM available. I think that is also, I think many of this online training stations are available to have this knowledge of the Steam Center or Innovia. So this is one more opportunity, you can see that. And finally, I think when I did my research project in IIT Delhi in mechanical engineering department, so what they are doing is we have developed a error compensation software for CNC machines. So what are the CNC machines? A computer controlled numerical control machine, that is called CNC. So what they are looking for, they are spending lot of crores of rupees for getting the accuracy in terms of microns. So the CNC machine will be having some sort of a set of encoders, decoders, sensors and all these things, right? So what they are going to do is they are going to calibrate these sensor systems based on the mechanical guide vanes. But after some time, maybe after 3 months or 4 months, because of this mechanical wear and tear, maybe deflections or thermal deviations, the calibration system is getting affected. Because of that, we are not going to get the accuracy. Suppose the people are, what we are doing is every 6 months or every 4 months, they are going to recalibrate the tensor CNC machine. Because when you break down a CNC machine, I think we are losing lots of money, because the CNC machine will be rated on hourly basis. So what our project is, so without breaking down the CNC machines, is there any way we can capture the error models on XYZ directions, and we are able to capture the errors, and when you take this original CNC program and apply this compensation and generate the compensated program, so that if you run the compensated program on the CNC machine, we are going to end up with the original accuracy. This is what is called the research project, and our BHEL Bhopal is our implementation partner, and IIT Delhi is, and MIT Ministry of Information Technology are our supporters. So I was worked under Professor PV Madhusudan Rao, like that. So I think this is one project we did that. And finally, these are all the technologies or skills we have been using in our day-to-day for satisfying our customers and satisfying the customer requirements, like NX, CATIA, SolidWorks, Autodesk Inventor, AutoCAD, MicroStation, programming like C, C++, Java, Python, all these things. Team Center skill set, it is a Team Center API, something like that. In ANSYS also analysis API like that. Okay, this is what other technologies we have been using that. Okay. So usually whenever you are coming up with software development life cycle, so these are the 4 stages we have been using that. So whenever you are coming up with any customer has come up with any requirement, first of all you need to understand the requirement. So that is called requirement study, and you are posing some questions to the customer and asking that, maybe getting the clarifications, and after that we are preparing some sort of a document called business relation document or BRD, something like that, and then get it approved by the customer. Once after that, we are going to create, once after getting the approval on the BRD, we are going to come up with the efforts, estimations and schedule. So these many efforts are required, these are the schedules, we are going to deliver the application on so and so date. And after that, we are start doing the implementation, maybe using the design analysis and code development and all. And finally, we are going to end up with the testing, quality testing, local copy to customer, something like that. Or quality testing we are doing that, and we are going to deliver to the customer. So this is our product life cycle management in our software industry. Okay. Yes. So before concluding this presentation, I just wanted to make sure that in mechanical industry, in aerospace, defense, as well as transportation, automotive, there are wide variety of opportunities. So there is no need to work on different industries like some sort of telecommunications, banking, insurance. There is no need to do that. With the programming knowledge, you are able to do many programs in our mechanical industries itself. That is what I wanted to say. Before concluding that, I think I just wanted to add 2 more points here, which is beyond the scope of this. So whenever you are getting it, definitely maybe after your end of your final year, you are going to get the jobs and you are going to get the salaries. So whenever you are completing, getting your salaries and all, so the first thing is we are technically good. but financially we are poor planners. So that is why whenever you are investing anything, whenever you are saving anything, you should have some sort of advice from the financial advisors. So instead of that, what we can say is just save something on each month and invest in the maybe systematic investment plan like mutual funds or something like that, and then do the expenses. So this is very, very important because we haven't done that in our earlier days. So that is why I just wanted to tell you people. So investing and financial planning is more important than earning the money. The last thing is, and whenever you are comfortable with your job, maybe after purchasing your bikes, houses, and marrying and getting the kids and all, do something to the society that is called social service activity, which will give a lot of satisfaction to you. So this is what I wanted to just give you. With that, I think I am concluding this presentation. If you have any questions or anything, we can answer that. We will see how to play those videos so that we will be getting more idea. Any questions or anything? No, is it understandable what I'm saying? I don't know. No, did you get any some sort of exposure on the what is aerospace industry or something like that? What are the opportunities available? Any questions, please? Please. Sorry?
Sir, I want a view of CAD packages.
CAD package.
CAD packages.
CAD packages are, many CAD packages are available. I think in the industry, most of the people are using our CAD packages like NX. That is from Siemens. I think I don't have the screenshot. In the video, I can show the screenshot. NX, CATIA and Creo. I think if you learn any of the things, that will be sufficient. This concept is same, but maybe terminology is different. But any CAD package will do the any purpose. So that is what. If you wanted to go for the analysis, ANSYS, NASTRON, Patron, or the different analysis packages, you can use that. Okay.
Sir, what are the challenges in design of aircraft?
Challenges?
In designing of aircraft or?
Designs, you are talking about software or you are talking about mechanical designs?
About mechanical design, sir. And
that is based on the part to part, right? There is always factor of safety, there is always some sort of procedure. So you have some sort of what is exception.
so they will give some instructions, sir.
Yes, that will come through experience.
Less noise. What are the situations, sir?
What are the
Factors that facing in design of aircraft.
So that is what because these components are not we are reinventing that. Most of these problems we have already faced. We have all these rules and regulations available with that. So we are just working for the improvements. So that is why I think most of the things are already documented, and your customers also will be providing those things. Some convergence criteria, all these things also are possible of it, right, like that.
Okay, sir. Thank you.
Any questions?
Placement opportunities from site. How can you help in these situations?
Good question.
Internships.
Okay, internships, actually before Corona, we have many internship opportunities in both mechanical as well as software. Because of this Corona, I think most of the people are working from home. There was no actual face-to-face interactions, and we are not all going to offices. Maybe 3 days or in hybrid model we are working. But good news is from October 1st onwards, almost all companies are going to office and working for a full week. So mostly I think from October onwards, maybe after 2-3 months, definitely we can start this internship. And whenever the opportunities are there, I think I'll inform your dean or your professor.
Thank you, sir.
Placement opportunities, I think scientists conducting placements through online only. So people who are from finished mechanical are going to write the test online. Once you get the test, complete your test, I think mostly some interview will be there, but most of the importance will be given to test, mechanical online test only. Like that you can do it.
Sir, can we know the eligible lists?
Can we?
What are the eligible candidates?
What are all mechanical engineers with first class will be eligible? Because more than 90% of the people are from mechanical only in my company. So TCS, I will give you again, sir. TCS, Quest Global, SCI Technologies, L&T Infotech are our competitors. They are also working for mostly for aerospace industry. There are huge, wide variety of opportunities are there. I think this will be there forever. We are not going to say that up to 2030 or 2035, not like that. Whenever the mechanical work is there, we are going to have it like that. Okay.
Explaining here, all the softwares are available with licensed things. So is there any chance for our faculty and students to have a case study projects from Scient?
Okay, this has to be discussed with I think the HR people, because I will tell you most of our work are working for aerospace industries, that includes military also, military and defense. So I think because I think I'm unable to get the pen drive access to my laptop because of that only. I cannot share anything. But what we can do is non-military data will be there, commercial data that can be definitely shared to people, so that you will be getting some sort of project. I think I'll just discuss with my team, and if any possibility is there, definitely I'll look into that. Yeah, thank you. That or not, but in that my lecture or not, but I think definitely you will be getting more clarity here. So this is the NX CAD package here. Okay. So on and above that, we have added our own menu item here, NX tools. When you run that application, you are going to see that NX tools. So this is the small components which is having around maybe 150 or 160, but just for the sake of time. So this is the component. Forget about this is the ground support engineering component. So what we want is, I wanted to extract the complete information of the geometry, surface area, center of gravity, moment of inertia, as well as total weight of each sub-assembly as well as sub-assembly by writing a program. So in order to do manually, it will take around 2.5 hours time. That is what, based on the number of components available. So what we have done is, we have automated this process, and then we are making a video for your understanding sake. Just I think I am just running that. Okay. See. Yeah. Now this is the component for just for the sake of this, and this is the model tree here, and which is having different sub levels and sub assemblies like that. Okay. And each one we have for each part we have a component name also is available here. So this is the I am talking about NX manual NX session only. This is okay. So in order to get that, I just is explaining here. And now this is our own menu item. There are different tools. When I click on get attributes, okay, there are other applications. It is asking you wanted to export the information outside or import the information. I am just clicking on the export. Import is something, if you change the component name, that's automatically getting updated when you import that. When you click on it, it is asking a dialog. This is the default name, file name is the assembly name, and where you wanted to save that location. If you click on OK, automatically we are going to cycle all the components, extract the information, and create an Excel sheet here with the required information. What is that? Part number, component name. This is the level, sub-level, sub-sub-level, as well as all geometric properties. Because some customer may want the geometrical properties, some customer is talking about the weight, something like that. That is why we have created different sheets, export sheet, material property sheet, assembly structure like that, and we are able to generate. Once we have the data, we can put it in any format like. So this is what is one automation. So I think this is when we have done it in 2007. So this is the first application we developed for Utah Aerospace, and right now also they have been using this application in that. So this is adding our own behavior to the CAD package. This is called customization, and we are using API. We are able to extract the required data and calculating it, and after that presenting the required format. This is one application. I think you will getting more idea now, I feel. Any questions or anything in this? Okay. Somewhat interesting. Yeah, again, see here, I think, see again we have created this NX tools here, and this is the customer copyright information. Here these are the views, I think we just. Yeah, these are the views. For this particular view, I wanted to add a whole location chart so that for the reference hole, all the information will be created like a chart. This is what is the automation without any human intervention. We are able to do it. The maximum, I already told, around 5-6 hours of work will be converted into 1 hour. So this example I have taken only for the sake of understanding. Like this, we have developed more than 200 applications for our customers in aerospace industry. So this is the way you can use your programming knowledge in the mechanical industry to automate this. Okay, let us see what is that. See, here also we can see, you can also add, this is application, internal tools and external tools like that. So internal tools are the tools we have developed for our company to improve the productivity, so that we are not going to share to the customer. The external tools are the tools we have developed for our customers based on their funding. So that is what. So like that you can add your own menu items as well as sub menu items also here. This is the way overriding the behavior of the CAD package. That is what is that. Okay. Yes. Yes. Yes, these are the applications we developed there. I am clicking on the whole location chart here. Now it is the copyright information is providing that. So whatever the customer has provided, that's what we are showing here. And after that, a dialog has come. Select the geometry type. You are going to create, forget about the XYZ chart, something like that. I am talking about the default whole location, I want that. So just clicking on that. If you click on the help manual, automatically we are going to show the Word document, how to run the tool or maybe something like that. I am clicking on OK. So this is the dialog has come. So first option is, if you are going to the select the particular view. See, these are all the way this is our own dialog created on and above NS CAD package. I will tell you all these things maybe while running the application. Now click on the select view button. Which view you want to select? So we are providing the option for the user to select the required view. Yes, he is selecting that particular view. Now after that, you wanted to create a circular holes or snap point. In some cases snap point is also there. We are going with circular. Now click on OK. What is the reference hole? Select the origin edge. See, this is the comment is there, right? So this is the one. So this is what, or anything you can select. When you go there, automatically it is getting selected. So this is called reference hole. From that reference, again click on OK. Click on that option. Now user can select any number of other holes. 1, 2, 3. Whenever he is selecting, automatically it is coming that. You can do any number of holes here. Once you click on OK, we have already calculated the horizontal and vertical dimensions of the particular hole from the reference hole here. User can delete here. See, numbers also there here. 1, 2, 3, 4, 5 have already come. So user can do this using delete option by using this, and move up or move down using these options here. So you can delete it right like that. So that automatically to be getting deleted. Maybe for the last one, there is no down button disabled, right? So these are the exceptions we need to handle in the application. So once that is done, you want to add some more, I can add it. Click on OK. So these are all the dimension information is available right now. Now it is, we are fitting it, and so do you have any chart breakup? So how many, total 21 are there, how many are required on a particular chart? I am going with 12 maybe, remaining 9 like that, and clicking on apply button. It is asking the create chart, you wanted to create a default location or you wanted to select the location where you want that. So this is the now chart is getting created. See this. See, these are all dimensions. If you go to that, if you go to the status here, it will give the horizontal and vertical dimensions. See how much time it will take to do it manually. Okay. Now the reference starts with 22. So like if you wanted to select again the select particular view, see select view, automatically the previous information whatever is available is already loading up. Right? You can add some more holes here. So this is what is the API we are using on NX, on and above NX, and we are customizing or automating the manual process without human intervention. This is what I wanted to. For that, what you need to do is, you should be expert in any language, any one language, not all. Because the concepts in C or C++ or Java or anything is same. The terminology is different, syntax is different. So if you are comfortable in one language, you can easily learn other languages also. The syntax and concepts, you can easily understand that. So like that, you can do many more things on the CAD packages. So don't worry about your future. We have ample of opportunities in mechanical industries using software. Okay. Any questions after seeing this video? Yeah, here this is one thing is, you can also save in CAD package, whenever you wanted to rerun that, you can also save the macro. But the macro saving will not work because it will be hard coded in that. But rather than that, we are writing our programs without hard coding in a generic fashion. Okay? Yeah, thank you for providing me this opportunity. And if you have any questions, you can ask that. Otherwise, we'll